Sobat Tiara yang hadir pada saat ini dalam keadaan yang sehat, dan bagi Sobat Tiara yang sedang menunaikan ibadah puasa, semoga masih dalam keadaan yang semangat untuk dapat mengikuti webinar ini dengan baik sampai selesai. Perkenalkan, nama saya Joseph Daniel Alfacorado, saya Reliability Technology Sales dari PT Tiara Vibrasindo Pratama, yang akan menjadi moderator dan menemani Sobat Tiara sekalian selama beberapa waktu ke depan. Baik, untuk topik yang kami bawakan pada hari ini mungkin sudah diketahui oleh Bapak dan Ibu Sobat Tiara sekalian, yaitu laser shift alignment versus dial gauge and the key benefits of easy laser technology. Seperti yang kita ketahui, proses alignment merupakan salah satu key factor atau faktor kunci dalam menjaga performa dan umur dari rotating equipment, baik saat proses instalasi mesin ataupun pada saat proses maintenance di plant Sobat Tiara sekalian. Namun, pemilihan metode yang digunakan untuk melakukan alignment dapat memberikan perbedaan yang cukup signifikan terhadap seberapa baik tingkat akurasi, efisiensi pekerjaan alignment yang dilakukan, serta hasil dari jangka panjangnya. Di dalam sesi ini kita akan melihat perbandingan antara metode konvensional, yaitu menggunakan dial gauge, dengan teknologi laser alignment, yang hari ini kami bersama-sama dengan prinsipal kami dari Easy Laser akan memberikan sharing di webinar kali ini, di mana Sobat Tiara akan diajak untuk memahami bagaimana solusi Easy Laser dapat memberikan nilai tambah dalam meningkatkan presisi, kecepatan kerja, dan meningkatkan reliability pada equipment Sobat Tiara sekalian. Kami PT Tiara sudah berkolaborasi cukup lama dengan Easy Laser. Dalam kerjasama kami berkomitmen untuk memberikan solusi dalam pekerjaan alignment bagi Sobat Tiara sekalian, di mana kami menghadirkan beberapa teknologi laser alignment yang akan kita bahas lebih lanjut di webinar kita pada hari ini. Tentunya di webinar hari ini saya tidak sendiri, saya ditemani oleh prinsipal kami dari Easy Laser, yaitu Sven Fleiser. Beliau merupakan area sales manager Asia Pasifik dari Easy Laser. Yang akan saya sapa sebentar. Halo Sven.
Hello, good afternoon. Selamat siang.
Halo Sven, selamat siang. Good afternoon. So thank you very much for your time today to be with us as our speaker. We truly appreciate your availability and your support for this session. So earlier, I have briefly opened the webinar and share a quick overview of today's topic, that is a laser shaft alignment versus dial gauge and the key benefits of Easy Laser technology. So with that introduction in place, I believe now we can hear directly from you, and please take us deeper into the topics. So without further delay, now you can carry on this session. Time is yours.
Much appreciated, and thank you, Park Joseph. Hello and welcome to everyone in that webinar. Pleasure to have you here. And thanks again to the company PT Tiara to organizing this webinar. So we like to talk about laser alignment and shaft alignment, and have also some comparison to the dial gauge alignment. I will start to share my screen.
Yep, it is visible.
Just give me 1 second. Good. So you should be able to see the first page of the presentation. We like to talk in that webinar about laser shaft alignment, but not only. So there's a small introduction about the company Easy Laser. We will go a bit back to the basics, why this is beneficial and typically driven by maintenance departments throughout the reliability-centered maintenance that applies today in the most modern and operating businesses. Some basics in regards of really what actually is misalignment and how that this affects the machine. Then we will show you a couple of examples in regards of laser alignment technology and how Easy Laser is a partner for potentially you, can help you to improve the operating of machines, so rotating machines and more, to benefit from them. Then in comparison to the laser alignment, also the way of how dial gauge alignment in the past has been performed, and what are the differences. Today's approach to laser alignment, a very small live demo from my colleague who is here in that meeting as well. His name is Andy. Just one more time, my name is Sven. I'm a German engineer working with Easy Laser. Andy and I, we are both based in Singapore. I myself being the area sales manager for the Asia Pacific region. To support our distributor like the company PT Tiara that we have in Indonesia. So I believe also after that kind of presentation and live demo that Andy is carrying out, a little later we have some question and answers and then the closing part from Pak Joseph. Very quickly about the company, Easy Laser. So in regards of facts, we are founded back in 1994. So good 30 years ago. That's the time when those electronics and digital way of capabilities have been used to build laser alignment tools for industrial usage. Our company is based in a town that calls Mölndal. It's situated at a suburb of Gothenburg in Sweden, so the second largest city of Sweden. We're having in that headquarter more than 100 employees. Those ones concentrate solely on designing, producing, and developing basically the laser alignment solutions, while our distributor network that takes care of individual markets, territories, countries. So a appointed partner in cooperation with Easy Laser, they are the ones that supporting all of the operations and the end user potentially like you're in their territories. Just to have an idea about the map, so we are headquarters situated in Sweden. There are some people in our operation that are located in Germany and in Singapore. But this is, just the part of Easy Laser itself, our distributor covering those kind of yellow marked countries here on the map. And we're having more than 80 of them. And those little drops that from digital maps, they are presenting service centers. A service center is a facility that is authorized to calibrate and to repair that equipment. So laser-based instruments and the detector has a high accuracy. We're talking here about a micron. And based on ISO certifications in operations like companies, etc., this kind of measurement technology typically is required to verify, and that means calibration. So the geographically closest to Indonesia, especially Sumatra, would be Singapore, where we're having this kind of facility to carry out calibration and repairs in addition. The other three in the APAC regions are India, China, and Australia. So that's mostly partnered and cooperating with us and offer this kind of service. We as company Easy Laser are, expressing, of course, health machine monitoring and corrective of the machine. So correctly aligned machine will have a longer service life and less unplanned downtime. And that is where then also the reliability-centered maintenance comes into play. They will also be more efficient in regards of energy consumption and need fewer spare parts. And this altogether contributes to a better work environment due to lower noise levels, lower stress in the machine, extending lifetime, and altogether with many different aspects, they basically saving money, or they do not consume as much money if a machine that would be in misalignment would do in the other hand. So we as a company in regards of our brand promise, really highlighting user friendliness to the usage of an app that you run on a display unit on site in that measurement instrument environment. So you can run it on your smartphone, and that is very convenient today to handle. Further, we are representing adaptability. So we do not have any licensing or software part that somebody needs to pay for. It is completely for free. And if somebody starts, to start kind of shaft alignment with certain basics, to typically learn very quickly how many other applications they can take care of with this kind of technology and potentially need to upgrade the systems with different hardware, emitter brackets and things like that. All of those things do not differ in regards of communication to the interface. So the interface, that means the app is completely for free. There's no layers of licensing included that you need to unlock something to get specific function. That is all included and for free. And the third part is, yes, that we are always precise and reliable with this electronics in a high precision way. Just 2 or 3 more slides. So about the company, we typically separating from the application, the products to target those applications into majority shaft alignment. So there are many different kind of layers or systems available for various purposes. Then we having belt alignment or sheath alignment tools as well, and that's a big part in addition, the geometric measurements. So all of them combined, talking to the one and the same app that runs on the interface on the display unit. In regards of, being on the market this 30 years, I like to highlight here based on our revenue, the last 10 years. So when you find this year 2016 in this chart, you see a certain number of revenue and compare that in the next 10 years, so kind of up to 2025, which is here not shown, but there we had around 300 million SEK. And this is basically a kind of tripling the revenue. And there are reasons for it. So Easy Laser, with the launch of the XT generation that we are also presenting today, have really hit the nerve of the customer. It is very successful on the market, and we have risen to the market leader in that kind of segment. So Easy Laser today is number 1 of the instrumentations that are used to align machines with laser. And I believe the most customer really complement that kind of usage in regards of reliability improvement to do the alignment of machines, rotating machines, and geometric measurements in their operations. Good. We are at reliability-centered maintenance, and coming a little bit back to why are we all doing that or should consider to do that. And I mean aligning the machines. It is really essential for machine installation and reliable, long-lasting operation to do the installation of the machine in the right way, especially from the beginning of the lifetime of the machines. That means during its installation. Typically, machines already installed and they suffer, they have problems. And yes, we are doing condition monitoring, figure out that there are many obstacles in the operation that creating certain symptoms, potentially vibration and heat, and figure out the machine is often misaligned. And we are starting to correct that. So reliability-centered maintenance typically goes on the top of this problem and is defined by improvement in time. So that means that the machines should be installed through the commissioning to the contractor and the operator at the very beginning of the lifetime to comply with certain standards and tolerances. So spending good money on new equipment but installing it wrong, or by unexperienced installers who maybe do not have the knowledge, will lead to downtime and unnecessarily expenses afterwards. So we like to protect you, your operation, your environment from those kind of events to happen. So monitoring the machine in its operation allows you an early identification of possible failures, and that is essential. But reliability-centered maintenance means actually we should try to avoid those kind of root causes that already exist in the machine because of different reasons in the very first place. So not basically wait that a failure is happening and that we recognizing it. We should install the machine accordingly to the specification so it will never create those kind of failures. That is today a modern reliability-centered maintenance about. So a reliable, planned, and proactive maintenance and defect elimination leads typically to a much safer operation, to more secure. It will be, as a consequence, more environmentally friendly. So I'll be talking here also about energy savings and things like this. Your operations will be, as a consequence, more productive, also therefore more competitive on the market and less stressing. When we may be going back into this, kind of asset management and maintenance philosophies, back in the 60s, the gentlemen Nolan and Heap, they have figured out with statistics that the most machines can be separated in certain pattern as they are operating in their lifetime. And against what the expectation of many people were at that time and still today, so those statistics have been proven correctly even just a year ago. So that's not something very old in the back that still happen. That the majority of the machine failure actually happen randomly. So when you look into the yellow graphs and figuring out bathtub, wear out, and fatigue, so we see a kind of an indication that there is a wearing out in time. So like during the operation, the machine gets worse and worse. But the percentage of the machine failure related to this pattern is very, very little. It's altogether only 11%. 89% on the other hand, they are failing randomly. And then there's the question, why is this happening? When we're looking at the very last one in the bottom right-hand side is the so-called infant mortality. So if you look at the curve, the greatest danger of a machine to fail is actually at the beginning of the lifetime. That is 68% out of all, and that is a huge amount. And I like to encourage you to really think about why is this the case? So why does the machine very often having a high danger to fail at the beginning of the lifetime? So that is something the reliability-centered maintenance today is trying to overcome. And the part of this, kind of material to teach and to make aware of are our responsibilities. So when we have an idea and target what we want to do, what is the application of the machines, the operation and so on, then we're going to the designer, to the engineering, and to the installation teams to acquire machines for that job. So there's a lot of communication and, coordination possible. So we are defining procedures of how these machines will be installed to benefit later from their operation in our processes. But most often we are lacking on integrity. So even though we know what is needed to be done and how it's to be done, we often do not apply that. So we're making mistakes, especially when we are dealing with different departments or even contractors. So machines need to be transported after they are purchased. They need to be put on site. They need to be installed correctly with certain tolerances and specifications. And there, the most people or the most failure happen actually. And this is what reliability-centered maintenance means. We like to avoid those problems. And this is basically up to us, all of us, to follow those kind of procedures that have been defined, having the knowledge about the effects, what we are actually doing in regards of those procedures. And we need to have the right tool to comply with the requirements, to access basically the condition of the machine, to make it comparable towards those kind of tolerances. So now in regards of laser alignment, why is this alignment so important at the maintenance? Strategies in the maintenance world are typically lean on the so-called PF interval. So there's still the old assumption that the machine in time will basically having a greater danger of failing. There are many different reasons why this has happened. And condition monitoring bites basically on the event to have tools available that measure symptoms. It is most often the vibration, thermography, ultrasound, and things like that. So with those condition monitoring concepts, you are trying to assess the current condition of the machine. But be aware of that this is a symptom. So when the machine is vibrating, it gives you an answer. It tells you something is wrong with me. And we are doing a deeper analysis on that, measuring time waveform, analyzing potentially FFTs. The same applies to thermographic and ultrasounds. And then we are triggering basically are figuring out what is the root cause for this failure, and we are fixing this failure. So this is kind of, reactive mode still, that we are reacting to an event that happened inside of the machine. And that typically in the time event happens between this P and F points of a machine, while the laser alignment, especially from the beginning of the lifetime of the machine, is considered to be happen much earlier. So to avoid this problem, the point where a failure starts or to occur, which is not necessarily age-related, that is where I can really make a big difference in regards of machine health. Today, still, we find machines with many problems out there in the industry, and the most of them, so 50% is it believed, are caused by misalignment. That is not only coupling or shaft misalignment, there are also other types of misalignment, like soft foot, the level or the flatness of the machine itself on the foundation the machine is standing on. So therefore, as a consequence, machines suffer, and the part that suffers most often throughout all of those kind of stresses inside of the machines are the bearings. So the bearings do not withstand this kind of tension, the stress, and they are failing most often. Less than 10% of the bearings today reaching actually their designed lifetime. They've just failed before that, and there are reasons for that, and most often it is in misalignment. The precision shaft alignment is a key to achieve high reliability in rotating machines. If you just imagine that you would increase the load on a bearing by just about 25%, then the lifetime of that bearing is already halved. Therefore, the lifetime is shortened, and you are coming permanently into the cycle to fix the machine and repair the machine. So my maintenance thinking is to make the machine healthy, so it will not come to that failure, or to reduce the possibility of that failure, and that means mostly bearings, couplings, and seals. So an alignment of a machine, that is when we are comparing it to a tolerance like the ANSI standard 3000 RPM, which is typically defined to have a permissible gap of 0.05 millimeter or less per coupling or working diameter of 100 millimeter. If you achieve that, then you are simply increasing the lifetime of that bearing, of that machine, and having a cost saving as a consequence. Now, when we talk about hundreds of millimeter, and even more often thousands of millimeter, because the coupling is typically smaller than 100 millimeter for the most common machines, we need to understand that you cannot really get close to that degree with using a straight edge in the worst scenario, to measure the flanges on the coupling, or potentially also dial indicator. Because dial indicator maybe have a resolution up to hundreds, but typically achieve only 1/10 of a millimeter. And then you actually also do not really measure on the shaft, which is of interest for us in regards of alignment. So coupling alignment refers to the shafts because the bearings holding those shafts. If the shafts are misaligned, then you have tension towards the bearing, and there you're damaging the bearing. And actually the dial gauge does mount on the shaft, but it doesn't really measure the shaft. You measure the coupling. We will come a little bit later to that. So there are many basically disadvantages or reasons why you would not be able to meet the requirements that are today applied to a machine by using dial gauges. So therefore, we believe to really improve your machine health in regards of reliability-centered maintenance, you need precision alignment. And that is typically achieved today in a level of microns or thousands of a millimeter throughout laser alignment gear. What is actually misalignment? Where does it apply? So we have not here really prepared in very specific industries, since I believe our audience is quite wide in different operations, but we talk in general about pumps, motors, gearboxes, compressors, fans, blowers, generators, or turbines. There are, of course, a lot of industrial machines that are transferring power. That is the core job of this machine. So transferring power means they are coupled with another machine. And therefore, the alignment for those kind of machines is really very, very important. We concentrate a little bit more in this presentation on some examples for the horizontal orientated machines. So besides that, you can, of course, do bore alignment, you can do flatness, you can do the parallel measurements on certain components in machine operations or vertically orientated machine. For today, because of the time, we give you an example in regards of horizontal orientated machines. So if you align those machines, typically you will increase the machine's uptime. You are reducing the operating costs. You are improving the processes, and depend what this process does, the product quality potentially. The environment, so not only the machine itself, also the environment and the people around this environment are typically safer. So you have a safer operations. You have less production losses, less bearing and sealing wear, and you are reducing throughout the elimination of a root cause, consequently also symptoms of the machine that typically show a problem. And that is things like vibration level, high noise, temperature, and so on. Coupling as well. And when I'm thinking about the coupling, there's still a huge disbelief inside in the industry that says I'm buying or using inflexible coupling. And this kind of flexibility on the coupling allows my machines to absorb, to compensate for certain misalignment. This kind of rumor is spread by those ones that selling this kind of couplings to be, more successful on the market, but it is just not true. So the flexibility of a coupling's purpose is solely made or given to transfer the torque, the rotational energy mechanically from one machine to the other. That is what the flexibility is for. It is not built to compensate in misalignment. So that is really must be understood. The consequences of misalignment are basically the other way around. Machines that are misaligned have really significant problems, mechanical and operation problems, and they are typically premature bearing, seal, and coupling failures. We're having all of this increased vibration, noise, and temperature, which is again the symptom. But they are also consuming more energy, because if I'm having a resistance in misaligned component in my machine, I need more energy to overcome that, to rotate the shaft. Therefore, the energy is higher. Excessive heat generation, which in cases can be even dangerous for the environment and for the persons around the machine. But most point actually in this whole story is the costly unplanned downtime. So if a machine is failing because of all of those, reasons, bearing problems, etc., then you need to take your machine out of the process to fix, to repair, and to bring it back into the operation. And this hurts the operations the most because you have loss of protection, which costs a lot of money. So to think about healthy operations, benefits of ROI, so investment in precision alignment tools are typically paid back very quickly because they are improving your operations and reducing the possibility and the likelihood of a machine of failure. Therefore, you increase your machine uptime. So proper alignment minimizes those risks and extends the lifetime for your rotating machines. This is just an overview to reflect a little bit on those kind of old, not so correct measurement methods. And it started way back with straight edge and the string wire, the feeling gauges. So they are measuring on the surface of the coupling rim face, like in this top right-hand side picture indicated, and it's a very visible, a very rough alignment. Besides that, we are measuring here on the coupling, not on the shaft, which is of our interest. Then there we had the dial gauges or the dial indicator, and we have a little bit of topic in this presentation towards the end. So traditional methods require here time, extensive knowledge to align this machine correctly, and meet the tolerances that are required for this machine. So when I see customer in the industry and typically in a large audience, when I'm asking about who is doing the dial gauge, it's typically the senior engineers. So those ones that have the experience, they have mastered that over a long time. So not everyone can necessarily align machines with dial gauges because it's complicated. You need to learn that. And you require a certain amount of time of experience to master that. But even the best dial gauge alignment tools and engineers do not achieve that on the same level where the laser alignment today can be. So laser alignment, laser shaft alignment is the today quickest, the most accurate form of aligning machines using modern technology for precision shaft alignment. And in addition to all of the comparison to coupled shaft alignment, they can also be used for measuring more complex alignment, like machine trains, cardan shafts, and further geometric measurements. When you think about line bore in a diesel engine, in a turbine, stern tube, or flatness digital level from the foundation in the machine itself. To give you an idea what actually laser alignment is, many of you surely know that, how a system looks like. Maybe some others do not. We have here an example what in system, in carry case, an ordinary shaft alignment looks like. So the heart of the instrument or of the package is typically the measurement units. So there are two, an S and an M unit. They are mounted, that's part of the package with certain brackets, with chains, with magnet adapter, etc. around the rotating shaft from coupled machines. There are additional accessories inside of this case, and the way how you are communicating, navigating through the alignment process is a display unit. So the display unit is a tablet, industrial grade, has multiple options, specifications, and so on. We from Easy Laser doing that app-based. So it's an Android operating tablet or industrial tablet, but you are not mandatory to use that. So Andy will show you later that this is very easily possible also to use on a smartphone, on any kind of tablet, as long as it is either iOS or Android-based. Because you just can download the app yourself from the App Store. As say, there's no registration, no licensing, no money involved. And then you are ready to go ahead. You just need to have the measurement heads or a system for a certain purpose of aligning machines. Another example, a little bit larger case because it contains additional components. So this called here XT770 Geo. The additional components besides shaft alignment would allow you to measure flatness, squareness, right angle, and things like that. So we really, in the last few years, have highlighted the importance of not only measuring on the coupling, but also taking care of the machine foundation, because the design of the machine assumes that the machine is really placed on a proper foundation that is flat and that is leveled in a certain degree, which the ANSI standard defines today. To verify those kind of parameters or the condition of the foundation, you need to access and measure that. And that you can do very simple with a laser alignment tool as well. So this GeoSystem has components in it that would allow you to do that. Coming back to the shaft alignment purpose, we're having those measurement units. They are typically sitting on V brackets that are wrapped around the shaft, but there are multiple options to do that, to access the rotating machine potentially with magnet adapter or other means. in regards of installing them. So this is where all the measurement comes from, where the accuracy sits in it with the 1 micron to take the data, and the app self guides you basically through the process.
Nggak apa-apa, itu
So
aja. Yang utama tetap aku dikirim ke tablet, tapi yang nggak ada summary-nya.
the interface runs on the display unit, which is an app. And as said, in the background on the right-hand side, we have the industrial-grade display unit, which Easy Laser can provide. It has an inbuilt camera. It has an IP66, 67 rating. Optional, you can have infrared camera inbuilt, and it's an Android device. But depend on, of course, your environment and also spend money. You can run it on a tablet or on a smartphone. Can be also industrial grade, so you have the completely option to choose between of those hardware platforms to just download the app on that instrument and communicate Bluetooth with the wireless measurement units. So this is about shaft alignment and potentially geometrics, but the app itself serves even way more. So there are components available that help you to align sheaths, so belt alignment. They are communicating with the same app in the same way, Bluetooth, completely for free on the application. We have a small vibration measurement tool that is on purpose designed and supplied into the industry. I would call it a nurse. So it's not the specific doctor level with a super, vibration data analyzer. It is something an engineer and technician that maybe do not have in deep training in regards of condition monitoring and vibration. It's a checker. So you check and you get very simplified information on that instrument about the rotating machine's vibration noise level that applies to the bearing, to the velocity, where typically unbalance, misalignment, looseness, and resonances applies, to give you the indication that this machine has a problem. It gives you in addition an FFT to pinpoint a little bit the direction, and that's why I'm calling it nurse. It's very easy to handle. You can use it over hundreds and thousands of machines, and those machines that potentially is a bit tricky to figure out the root cause, then you're engaging into an expert, potentially a contractor, somebody that has another tool and the knowledge to do deeper troubleshooting analysis. In regards of geometrics, we have already seen that in one of the cases. So the larger on the bottom right-hand side emitter, laser emitter are self-leveling. They're not self-leveling, you leveling basically the emitter by hand per gravity. So they identify the gravity, therefore the precision of the level itself and 2 axes. We have a 3rd axis when you like to put it sideways. And then we're using the laser beam as a guidance. That is our reference, and the same measurement detector that you have seen earlier from shaft alignment takes data from different measurement positions. So this is basically the summary of how to measure flatness and digital level with a laser shaft alignment system. So those components are in addition, depend on the application that you really like to measure, and all of them communicating with the same app. Inside of the app, just to concentrate on that example on the shaft alignment, we typically have, after the welcome page, chosen to do shaft alignment. And then you see a machine like that. So the top right-hand side picture is where we are starting to get a digital clone of the machine. So while you have installed the hardware on the machine, on the shafts, we still need to understand about the angularities. When we measure between in stationary machines, so here in that example, our left-hand side, and then we have as a consequence a movable machine on the right side. So they need to know where is the axis towards the alignment in regards of angle or gap misalignment. So the center of power transfer, there we need to have the measurement. Where is the center in regards of the position of the measurement units they are mounted? Then next you have the dimension of the machine feet, because the angularity of the machine, of course, is increasing into a real gap per distance. So if there's an angular misalignment, the instrument tells you also the correction of the machine, and the correction applies on the machine feet. So to calculate the necessary correction values, to bring the machine into that acceptable range per tolerance, we need to understand in which dimension those machines are situated. So a couple of measurements to key in, and then you have your digital clone. Next would be the input of the speed of the machine, so the real revolutions per minute, because they are defined in categories in regards of the tolerance that applies to that one machine. So tolerance for coupled machine is referred to the ANSI standard, and they are inside of the instrument where all of those tolerances are existing. The machine speed information is taken to choose the right tolerance. So basically your target, that you compare the condition of the machine that you are measuring with that target. So that's in a minute or so done. Then you have basically created the machine as a digital clone and come to the next point forward to measure. When I'm saying measure, I recommend to do the soft foot alignment or measurement before you are starting to do coupled or laser machine alignment. So you have the measurement units on the machine anyway. And while many people prefer to measure soft foot with a dial, with a feeling gauge on the foot, we of course like to measure that where it matters, because the soft foot affects the operation of the machine. That means the rotational energy of the shaft. So we are interested to make the machine healthy. And that refers to the rotating shaft in its support, in its bearing. And that's why we measure with the measurement heads on the shaft. So when we are having then this soft foot menu, it goes a little bit further in the program, and you are requested to loosen the tightening bolts. So when there is a soft foot existing, it shows you a relaxation. The machine is really moving because you tension and you bend potentially the machine feet, and this is measured on the shaft. So if there's a soft foot or a movement from greater than 0.05 millimeter on any of those feet, this is typically recommended to be corrected, because that stress towards the machine and its bearing is too high and need to be compensated mechanically by shimming. And it is really beneficial to do that, because in the industry is now well known that the soft foot is the silent killer of machine operations. And you help yourself actually to eliminate the soft foot in favor of aligning and later correcting the machine position better. Because if you correct the machine with a soft foot, or if you try that, it's very, very hard to do if the machine has a soft foot. Excuse me, please. After the soft foot is done, after this corrected, you can go into the measurement mode for the laser shaft alignment. And here, depend on the instrument that is chosen to be your shaft alignment system, you have various options to take data. So the installation of the measurement units with those brackets do not differ. You have the classic 9-12-3 measurement method, which refers to the dial gauge positioning to ease those people that have done dial gauge alignment into the same way to do that with laser alignment. We recommend to do that with easy turn, excuse me, because it has also 3 measurement points, but they are more flexible. So you do not have necessarily to measure them in 90-degree angle to each other. The smallest permissible angle in positioning of the shaft between those 3 points or each point can be 20. So in summary 40, that means the smallest rotation angle which we can measure and identify the alignment condition is 40 degrees. Mathematically, it's better if the angle is greater, but typically you can rotate minimum kind of 90 degrees in summary. With multi-point, you can take more data. It's dependent on the application, on the machine, on line of sight and things like that. So that's basically your choice, that you have multiple options that situate multiple kind of applications in machines. The most convenient today measurement mode that is considered is the fourth one in this category, the sweep. Sweep takes in a couple of seconds hundreds and thousands of measurement readings. It's a recording. So you basically just start the recorder and you rotate the shaft. And all of this data is taken and calculated, processed inside of the app automatically. So you do not have to stop and hold on certain position. It just takes the data. My colleague Andy will show you that soon. The last one is the so-called uncoupled sweep. So this is for machines where you have a shaft that you cannot rotate. Obviously, the shaft alignment requires a rotation of the shaft to take the data. If you have a machine, a gearbox, multiple machine components assembled in a train, then you potentially cannot rotate the shaft. To overcome that problem, you take out the coupling and you're using magnet slider to slide on the stationary shaft. And therefore, we have a designed measurement mode called uncoupled sweep to measure that in the most convenient way. When you have gathered data, you are informed by the program about the condition of the machine. So with the initial setup of tolerances, speed, and machine dimension, they are indicated in colors. So you can see on those two examples, at the top, we have the vertical view of the machine, at the bottom, the horizontal, that they are all in red. So we are outside of the tolerance. On the bottom of each of these graphs, you see those little numbers next to machine feed MF1 and MF2. So one's in vertically and second and horizontally. So this is the amount that is required in regards of correction. You need to adjust this machine by shimming vertically and moving the machine horizontally. You can prepare your job that you need exactly those kind of shimming for vertical. You can prepare it or have it on site. In the next step, you would basically go further and do the live adjustment. So while the measurement units are still on the machine, you can kind of measure completely live and correct the position of the machine. So there are different measurement or correction modes available. We have this in a small demonstration as well from my colleague Andy. And you bring the machine basically into range inside of the tolerance that is now at the bottom of the picture shown, that those colors, those values are fitting inside of the range of tolerance into the green and yellow range. And then you're good. Your machine is basically tightened again. It complies with the requirements. You're doing typically one more measurement turn to have in record about as found and as left as an evidence that you have corrected the machines and brought it in a condition that complies with the specification. And then you are proceeding to the reporting. So the software that is included of the app allows you to have immediately the reporting available through our templates, all of the data, whatever you have done in the shaft alignment, as found, as left, with soft foot, the dimension, all of those things are protocols. So that's basically the chain of evidence that we are providing through the process, because the instrument serves as the tool that comes with the needed accuracy. It's not from the engineer. So that's really a consistent way of providing evidence if you think about a service contractor, compliances, and things like that. So everything is protocoled and then can be expressed in the stored measurement data, converted to an PDF file, to an XML file, and then shared with multiple ways. Either on a USB thumb drive, you can, from the instrument itself, send it out via email. You just need to hook it up to a hotspot. the latest what we have done, we introduced the so-called Easy Laser Plus. So that's a cloud communication. It serves as a gateway where you are pairing your app with that cloud, and with any internet connection, it synchronizes the data automatically. So that makes it available through cloud communication and browser access for anybody you like to share this data with. So you don't need necessarily to send those reports anymore. You can access them through cloud with any kind of modern browser today, just throughout internet connectivity. So with this full job done, results after the alignment, the key upsides from a properly and precision alignment on the machine shaft alignment are that they are reducing the vibration. The proper alignment minimizes this kind of vibration, which of course damages bearings and other machine components. You're extending the equipment's life. So motor pumps, couplings last just simply longer if they are correctly aligned. You are reducing the stress inside of the machine, the tension. Therefore, the engine that drives this machine requires less energy. So misalignment increases power consumption and proper alignment reducing it. So therefore you are serving as a possible way to improve your carbon footprint. You are reducing the energy consumption, which costs money anyway. But the greenhouse effects today, the thinking in sustainability, you are reducing energy. That's a good thing. You lower the maintenance costs, you're having fewer breakdowns and less frequent repairs. So you as the potentially engineer and technician that works in this kind of departments, potentially maintenance, you are responsible of improving profits because you are reducing the maintenance costs. And what I mean with maintenance costs is repairing the machine. So you concentrate of doing the job to make the machine healthy instead of repairing it. So you are still a very, very important part in this whole concept because you need to measure and you need to reliability-centered maintenance thinking go ahead of the problem to make it healthy. So higher operational reliability, aligned machine perform more consistency and they are reducing unplanned downtime. So there are many, many benefits where really today maintenance operation people and the assets are benefiting from to increase productivity and saving costs. This was the outline of reliability-centered maintenance about the components for misalignment and how to overcome them with precision laser alignment. Next, I have a couple of slides in regards of dial gauge alignment. And I do not like to spend too much time on them because it's kind of very complicated, especially showing true picture. But I think, if you have an idea with those kind of graphics, you will realize how complicated it can be. So dial gauge alignment has many different ways in the assembly of those dials with certain brackets on the machine across the coupling. Those most famous in the past that has been used is the so-called rim phase and reverse rim method. So there are ways to measure with dial gauges that pointing with the plunger on the surface of the coupling, even though they are mounted, excuse me, with the bracket on the shaft, what you are really measuring is the surface of the coupling. And this is maybe not the rotational center line. So we with laser would actually measure with the laser representation bracket mounted on the shaft, the really center of the rotation shaft, which does not have to be true for the coupling. So that's already a little bit a point where dial gauge alignment differs a little bit because of the technicality, which does not allow you to achieve potentially those kind of tolerances or desired accuracy. When we're looking into the variety of brackets, brands, and dials that exist, there are hundreds and thousands. There are all kinds of design existing. And it's quite hard to learn some of them, how they do be assembled, in which way, in what kind of assembly towards each other. It is not easy to put those dials correctly on, pre-tensed with the bracket barsec and things like that. So if you're looking into the animation on the drawings here, considering those rim readings and face readings, typically measured 4 positions in this 180 degrees against each other, so 12 to 6 and 3 to 9 o'clock. And we are accessing basically, excuse me, maybe I should drink something, just give me a second. We're accessing throughout the displacement when we are rotating the shaft that affects on the plunger of the dial, how much stress is inside of the machine. We measure on the coupling. And therefore we figure a parallel misalignment and an angular misalignment. And you really need to be trained on that and learn how to do that correctly. And it comes with experience, long lasting. So engineers today, they are not anymore that many who can actually correctly measure with dial gauges. I have done that, I can do that, but I will never be as good or as fast as I am with laser alignment, which is by far easier to handle. So rim and face, different mounting alternatives. There are really many options, depend on the situation of the shaft with coupling, uncoupled, etc. And by right, you would basically need to learn and know all of them, and depend on the arrangement of the dials, the kind of readings need to be really understood to then do your calculation of the alignment by hand, because the dials do not tell you about the alignment of the machine itself. You have to take those readings in the correct way and doing the calculations by hand. You basically have a measurement program in Excel that allows you to convert the data and is doing the calculation, but it is not done by the dial gauge itself. And here there are a lot of mistakes happen, is misunderstood, depend on the arrangement. It is really a tricky thing. Another thing is the so-called validation rule, that we have this classic top plus bottom versus left and right, as mentioned, that those two pairs with 180 degrees shifted from each other need to be compared. And also there happen mistakes, that the data have been mixed up and then wrongly calculated. That is really something to be aware of. When we think about the reverse rim, different mounting alternatives, so the reverse rim and the cross dials, the whole story changes because the dials, or at least one of them, is now upside down. So you get negatives and positive values, and all of this really need to be handled very careful. And just learning or knowing them is needed, but you need also to have the experience to know exactly how to handle this kind of data. Just one more example here about those fixtures in the reverse trial. So the contact points of those fixtures need to be really understood. That those brackets that are mounted depend on the equipment that is used, is here to be assembled in a correct way. The challenge is a little bit summarized from dial gauge indicators are mechanical limitations inside of the bracket and the dial itself. Then they are very, very dependent on the operator. We have made tests with customer also on our own. The same machine, the same dial, the same bracket. If you take two engineers, they are repeating the measurements, you typically get two different results. Because everybody kind of, installs them in a slightly different way. And there you have a lot of, let's say, variations of interpreting the data. Then calculation is important. And then you are not yet on the adjustment. So all of these findings, the calculation need to be applied to the machine towards the feed in regards of adjusting the machine. And one major, disadvantage from this whole system is the documentation. So today you are required to prove and to document those kind of things, corrections of the machine. And this is with dial gauge hard possible. You are relying on a hand protocol that you maybe write yourself in Word or Excel. but it is not really representing the measurement tools itself. The engineer is doing that, while the electronics, the digitizing from a laser alignment system allows you to have this report immediately. And it is basically therefore user independent. So it's really a digital kind of way to secure the completely process of the machine correction and alignment. A little bit further in regards of mounting on which shaft. So which one is actually the stationary machine and which one is the movable machine? Depend on your how do you have access to this machine from the left, from the right side. And that's where people also start to struggle with, to mix up things, which the dial is reversed, basically installed, depend on where you are as an engineer towards the machine. Then another kind of potential, I would not say failure, but chance to make a failure is the discussion about the flow of the energy. So the flow of the energy from the stationary machine towards movable machine or other way around defines of how you look at the machine. So we see this little indication on the bottom right-hand side, the point of view, because this one defines where is 9 and 3 o'clock. Everybody knows where is 12 o'clock and 6 o'clock, but 9 and 3 is often mixed up because people, especially mechanics versus the electricians, looking at the machine the different way. So this is a classic mistake that happened, that 9 and 3 has been mixed up. So consequently, those rim readings in regards of positioning will be, of course, reversed. So plus becomes minus, minus becomes plus. And that is very important to understand. And yeah, again, to learn. The same applies for the phase reading. That the 9 and 3 o'clock depend of the orientation of the machine, need to be really done correctly, or know what is the correct way to do that. Another example that I had a couple of times, and most often with user in Japan and South Korea. So there, this kind of dial gauge alignment usage is still common, and they always challenge laser alignment. So they say, I'm the master in the dial gauge alignment, and I do not trust so much the better technology to be considered. And often, yes, we find differences. So by testing a machine, once with the dial gauge and second with the laser alignment system, we're not getting only better accuracy results, the results will be also different. And it was revealing with one of the customer in Japan that, of course, has doubt that the laser alignment measurement was not correct. We have proven him wrong, because this person did not understood the influences of Barsag. So this pre-tightening of the dials against the gravitation. So to measure between the position from 12 o'clock versus 6 o'clock, major huge impact to this person's measurement. Even though he has measured with dial gauges many years, he has not correctly compensated for the Barsag. This applies to the knowledge in regards of how to install the dials correctly. Then also how to determine basically the compensation for Barsag, how to do that. So there is really a long guideline and training material. So bottom line from all of this is dial gauge alignment is complicated. And we talk here about standard shaft, standard coupling only. It needs to be learned. It needs really to have many years of experience to master that. And even though if you have mastered that, yes, I believe you can achieve in horizontal dial gauge alignment on a coupled shaft, but maybe not in the range where the specification or the tolerance requires it, not good enough. If you come across a vertical machine, it becomes even more challenging to do that right. A machine train already, so multiple coupled machines, is really, really difficult to manage, to calculate, and to get it right. For cardan shaft couplings or machines, and for geometric aspects like line bore, flatness, and things like that, there's no way to do that properly with dial gauge. This is all very easily taken care of by a laser alignment system. So this is the benefits of laser alignment in regards of dial gauge. It is way faster. It is much easier to handle. It is way more accurate. It does not depend on the end user. That's the electronic core. It serves the technician as a tool to access the condition of the machine, and it is completely digital. So this 1 micron accuracy in regards then also of accessing the condition and correcting the machine leads to a digital protocol that serves for you, the technician and engineers, as an evidence that you have corrected the machine potentially and left it in the desired quality, in the desired specification to meet the requirements. In summary, altogether, dial gauge summary, the advantages could be said, yes, they are of course lower in price. They are, there's no doubt, lower than a laser alignment system, but they're also very basic and rugged in its way. So they are limit possibilities in regards of measurement application and machines. In the best scenario, they can maybe have specification up to hundreds of millimeter accuracy, but in the practice, you very likely will not achieve that. So you are achieving potentially tenth of millimeter accuracy. The disadvantage of the dial gauge is it is very dependent on the operator. As said, two different persons likely coming to a different result. It is just how this works with the brackets. That requires a very long learning curve to master that. So training and expertise or experience is here required. It still comes with many risks to make mistakes. It lasts a lot longer to measure and to calculate and then to correct the machine. And it has limitations in regards where to apply to. And for me, the greatest disadvantage is the way of documentation, because I do not have a really digital proof. Even though you have potentially made a report, the report is made by a person. And then it comes to kind of trust and integrity. Today's, compliance is typically referred to have this kind of validation of quality work done by the instrument itself. And that is done throughout the laser alignment system itself. This is the end of the presentation, and I would hand over to my colleague, Andy, who is doing a small camera view on his screen to demonstrate very briefly how the laser alignment system with one of the easy laser equipment could look like.
Thank you, Sven.
Thank you.
Yeah, good afternoon, everyone. I'm Andy, Sales and Application Engineer from Singapore and also located in Singapore. So my task today, before I start, let me share my screen with you. Share screen. One moment, share screen. Camera. Okay. Together with this app over here. Let me close this one. Okay, so I hope everybody can see my screen. So what I will be doing today is, yes, I will talk a bit more on our XT app. Then I'll be doing a shaft alignment demo, shaft horizontal alignment demo, how to input, measure, and adjust. I'll do another one for belt alignment. Okay, belt alignment. Same thing, input, measure, and adjust. So before I start, so I want to tell you how easy it is, to download our app. So for Android users, you need to go to Play Store, search Easy Laser, and install our app. So it's free. It won't take up a lot of your memory. You don't need to pay any coins or absolutely free. Don't need login or anything. So once you install, you can click on the app, then it will go to the main menu. So from here, as you can also try to find out by yourself when you have time what kind of function can we do, can easy laser do. Okay, straightness, easy trend, twist, belt, and vibration. All right, of course, you do have to give access to camera if you want to take some photos. All right, so let me start with a demonstration on this shaft alignment rig. Okay, so this is our, one moment. Okay, so this is our XT770 with our XT12 display unit. So what I need to do now, everything has been set up with XT70S and XT70M. Okay, so let me turn on. So from the app, let's say if this is the shaft horizontal, so I start with a new one. Okay, so it comes out with this 3D picture showing a pump and a motor. So if you have time, you can also go in and change the configuration to other things like compressor. So, but today I'll be using pumps and motor. So same thing, S and M, the distance, you need to input the distance, tell the system what are the dimensions before they can calculate and give you a result. So for S and M, one 20. Okay, so S to center, by default, it should be half, which it is. You have to key in the RPM. Okay, for D. Okay, so once you key in all the dimensions, then you can choose over here. So what is the RPM, the tolerances that you want. So this time around, I'm choosing tolerance from NC standard, coupling diameter, or coupling type. All this you can choose whether it's a short flex or a spacer shaft. So by default, it's 100, but let's say if I were to do a measurement, is at ours is at 90. Okay, input all in. Same goes here. You can change the configuration as well. Okay, so on the tab there are 5, 1, 2, 3, 4, 5. So the first one is to enter the dimensions. Then they will tell you tab plus to measure. So from here, you can start to measure if let's say what you need. Okay, so because it's connected, if it's not connected, usually they will give you options to choose. What is the serial number? How are you going to connect? So I can disconnect, then also connect them again. All right. From your side, if I understand that you don't have a device over here, but you have an option to use the demo unit from our app. So from here, you can do it yourself also. But for this demonstration, I will need to connect to the real thing. Connect to the real devices and do a demo. All right. So both lasers are centered together. What I need to do is I'll do two measurements. One is easy turn, one is sweep. So as Spendic explained just now, you need to, the smallest by default is 40 degrees. So let's start with easy turn.
Andy, hold on a
Sorry?
moment, please.
Okay, yep.
I just noticed something, and it's maybe worth to mention to the audience. So the two left-hand side polar diagrams where you see the laser dot in the center, that is basically the two measurement units. That's a dot laser 2-axis PSD, and you see the vertical and horizontal axis. That yes, the laser beam is in the center, but you see also the degrees. So when I'm thinking about what I said earlier about the hassle, with 9 and 3 o'clock with dial gauge and communication, can you close that, please, Andy?
Okay.
Just
Okay.
close yeah. On the left-hand side, you see the 120 degrees from both units. So this instrument takes care of that automatically. You don't have to be worried about us doing something wrong with the 9, 3 o'clock, because the measurement units measure their own angle in its position when you're rotating the shaft. So Andy, when you're now rotating, please, to 12 o'clock, it is supposed to be 0. Could you do that, please?
Yep. 10 to 12 o'clock.
They are permanently live transmitting now with the app, and you have all of the data that you need. So it's by far easier without all of the hassle that you would typically need to take care of when you are doing that with a dial gauge.
Okay, 12
Thank you.
o'clock now.
Thank you.
Okay. All right. So let me carry on with easy turn. So usually we have to turn the direction of the motor. So just can start at this angle. So get data. But by recommendation, you have to register at the green, but no problem. You can get the data here as well. Okay, register value. So the values, this is the results. So I'll do another one, which is a sweep. For sweep, once you click on the green button, it will automatically get data. Let me show you. Okay, so it will automatically collect data until you press the stop button. Okay, so when you turn, so taking a lot of points. Okay. Okay, so another set of results. So you need to click on the next one. So as found, so what are the misalignment that you have? So for vertical, yeah, so for over here, that means the machine on the left, that means the pump is lower than the motor. So over here, you need to add shims, but for the benefit of demonstration, I will do the adjustment on the horizontal part, where you shift the machine or the motor towards me or away from me. So this is as found. If you click on the next tab, it shows you how to adjust. So for Live 360.
Andy, hold on a moment,
Yeah,
please.
okay.
So sorry to interrupt you. I'm just read a little bit through a couple of the messages in the chat. Please do me a favor and go back to the settings from the very beginning.
Settings from the very beginning.
And click on the coupling plus.
Coupling.
So one question is, how could we handle potentially dynamic stress, which is terminal growth, pipe strain, and things like that? The XT770 with its components has a feature inbuilt that calls easy trend. So it would use the same measurement units, but not mounted on the shaft, mounted on the body of the machine. And then you are measuring in a recording mode, potentially over hours, if there would be any compensation required. So what you really measure is the deflection, the growth of the machine between cold and hot, non-operating and operating. So the tool includes basically a feature that allows you to measure, does the machine has any dynamic stress related to its course, to identify how much that is. and you can use that value inside of the setting called thermal compensation. Could you click on that, please? So this kind of growth need to be compensated for. So that the alignment tool or the shaft alignment can do that, you just need to key in how much that growth would be, once in parallel and second in angular for vertical and horizontal direction. And then you would align the machine, including that compensation factor. That means it would be perfect aligned in its operating condition, not in the condition when you are doing the alignment, which is typically called potentially not thermally expanded. The smallest angle, that's another question that we would be able to measure with the rotation that Andy has shown, is 40 degrees. So with the dial gauge, you typically would require to measure 180 degrees, actually in best scenario, 360 degrees. That is where the laser alignment comes into play. Throughout the live measurement readings or the easy turn with just 3 points in a rotating angle of 40 degrees only. So that's the smallest possible angle that we can use with that system. It's good enough in regards of smaller rotating angle. So 40 degrees or 20 degrees between the 3 dots, between each of them towards the next one, that is the smallest angle the system can measure. Okay?
Okay.
Sorry to interrupt you.
No problem for them to understand more. So over here, just now I was started to do adjustment, live 360. So now what I need to do is to bring the motor towards me. Okay, so minus and plus. Sorry.
Yeah, so sorry to interrupt again. Just to explain what is live 360. So that system, the XT770, would measure time simultaneously the movement of the machine in every dimension. So with the capabilities to measure vertically and horizontally in the same time and into the same position of the measurement units, means that you do not need to rotate them during the process in any other position. You keep the rotating shaft with the measurement units in its place, and it measures all the dimension vertically and horizontal live all the time. Thank you, Andy.
Okay. Just a quick one. I show them adjusting.
Andy is already in
Okay.
that live move, and you see when he is adjusting those little screws,
No.
like the jack on the side, he is pushing the machine basically horizontally.
Pushing
and
away from me. Yep. So okay. So
it's indicated on the bottom. You see those little arrows next to MF1 and MF2. So depending on the position of Andy, you would basically being told that the machine on the drive side needs to come to you or further away from you. Same to the non-drive side. So then you have a clear indication in which direction you should correct the machine.
okay. So adjusted the horizontal part. Then you click the next one. This is where you can print the results, the reports as found, and also as left, as found results, and as left. So from here you have choices like the layouts. What kind of layouts do you want? From here you can choose. You want to save this as a template. Maybe you're gonna do another shaft alignment in 6 months' time, or you can finalize the results so that you can create a PDF from here. So finalize the measurement. And from here, you can create a PDF. It will be in your file manager later. From here, you also can share this report via email. Yeah, it says share. Then also layouts, Excel format. Yep, I can show you. So file manager, this is the last reading that I have done. Okay. So next to the belt alignment. One moment.
So this is just an add-on that we have these tools, and we are the only one worldwide with the capabilities of the instrument to really measure digitally the alignment position of sheaves. So we're having an emitter and a receiver. The receiver is connected to the app. It is the element that really measures in the high accuracy the positioning of the sheaves to each other, and then they will quickly demonstrate that.
Okay, this is our BTA, belt transmission alignment. So for this time round, you have to click on the belt button. So this is for belt alignment. Same, once you need to connect the detector, this is available. So it's connected, it automatically adjusts to the correct side, then or you can choose left or right. But this time it's auto, so you need to input. Here is about 150. Okay, so I click on the plus. Shift width is about 20. Diameter about 190. Yeah, 190. So you can also choose the tolerance, what kind of angular error would you want? So 20 degrees. RPM. Then over here, they have three tabs. Straight away, you can go into, so just now is input, now is measure, and plus adjustment. So over here, you can see the grid view. What kind of misalignment do you have? Is it a vertical, horizontal, or what kind of angle? Or you can choose a 3D view. You can turn it like that with your fingers. But for me personally, I prefer the grid view for this one. Since it's already live, what I need to do is to adjust the angle. Just a bit more. Okay. So just to perform this adjustment from misalignment to alignment. The same thing after that. You can have a report. What kind of layout do you need? The default one or the basic one? Basic one only have numbers. You don't have any illustration on any photos, pictures, right? So you also can do a finalization, finalize, save as PDF or Excel, then you can share. All right. So after this demonstration, I really hope you guys can download or even install XT app to try. Okay, Sven, that's all from my side.
Andy?
Yeah?
Could you do us a favor and open the browser quickly on the shared screen?
Yeah, our browser? okay?
Yeah, the
Or
computer browser. So I mentioned the plus, that this is a cloud communication, and I believe, Andy, your phone that you have used for that measurement is already paired with your individual space. So we offer basically end customer to register on that, plus that you get your own space to speak, where you can then have all of your data from the apps synchronizing their data towards to. So that basically could eliminate the communication of sending reports, because all of the data that exist inside of the device of your app in regards of alignment will be synchronized to that cloud space. It's a Microsoft Azure space that we basically provide to the end customer. And this allows you to handle other person's access throughout this information purely by browser access. And you can configure also where this data, the measurement belongs to, create a machine. So if you are then later measuring the machine again, you can use the last reading as a template, so that you do not have to have the need for the new inputs of dimension and things like that. So you can actually handle them like templates and apply them to the same or similar machines. For companies that having typically more than one device or app running, it allows also to have all the data synchronized just in one space, and that is the cloud. So the communication can be synchronized throughout the cloud to all of the apps, to the devices, and that makes the usage very, very user-friendly. We're having the cooperation with the company Vestas, so wind power. They're using thousands of those easy laser instruments worldwide. And they have mastered actually the guidance in regards of tolerances, dimensions for certain machines purely by templates. And handling that through cloud allows them to basically update all of the field located apps on the instruments automatically. So they can centralize the work quite easily. But for many purposes, it serves you also as a backup of your data storage. So whatever you do on your instrument, if it is hooked up to the internet once, it synchronizes data and your data is safe. So I think, Andy, you have showed it very quickly. That is your app, and there are the last measurements ones for belt. That is the PDF report. The zip file contains basically the raw data of the measurement instrument. And number 3 and 4 on the list from the top is the shaft alignment data. Thank you.
thank you very much.
You're welcome, sir.
Thank you so much for your attention. Now we're handing over to Joseph.
Yes, Sven, thank you so much for the insightful presentation that you have delivered. And now it's time to move to the Q&A session. Maybe in this Q&A session, we have a very limited time. And as we can see in the chat, we have received numerous questions from our participants today. So I think we'll go through the remaining questions. I already have the question, already have answered some of the questions, and we still have the remaining questions to answer. So maybe I will read the questions one by one, and you can have a response after I read the questions. Does it sound good to you?
Yes, of course.
Okay, so let me check. So maybe this the first question. Can the laser alignment system can be used for turbine alignment in situations where it is not possible to rotate the shaft during the bottom schedule?
So turbine means the shaft of the turbine to a generator, gearbox, and things like that.
Yeah.
Yeah, so the one measurement feature that we had in the list, the last one out of 5, called the sweep mode, or the uncoupled sweep, that is the name, sorry. Uncoupled sweep is designed for that purpose. So it would allow you to use magnet slider that are mounted to the shaft that you are not be able to rotate. So typically you would uncouple the shaft. That means one machine's shaft you typically can rotate while the other not. So when you have then the magnet slider on the non-rotating coupling and the machine is uncoupled, you rotate the other shaft and swipe basically over the stationary shaft or the stationary measurement unit. You have to do that once. Then you pause, or the system pauses it automatically for you. Then you can take off the magnet with the stationary measurement unit and change it in its angle position to another location. So then you can do your second swipe. We need to have 3 measurement points in a rotation angle of 40 degrees or greater. So you have to do that 3 times, and that's kind of convenient to do that with this magnet on a non-rotating shaft. If it's really very extraordinary that you cannot rotate any of the shafts, of course, that's a kind of a compromise you need to handle. Then you potentially would use the magnet slider to slide on the stationary shaft. Now that's not perfect because we would measure imperfection of the surface where those brackets are mounted on, but that is the best possible way. It is not the most best way in a way to speak, but it is a good compromise to overcome this situation. So uncoupled sweep is in measurement feature that allows you with the XT770 to measure machines that have a non-rotating shaft. So it means automatically for our thinking that you are taking off the coupling, so uncoupled, and then you have the sweep function to do that.
That's fine. Thanks for the answer. And maybe we can move to the next question. What is the maximum distance for accurate measurement of the device? Does the accuracy decrease under bright lighting conditions, such as during daytime?
So the instruments depend on the system itself. The most of easy laser instrument shaft alignment can reach a distance between those measurement units of up to 20 meters. And it is specified, tested also outdoors under sunlight with the dot laser. The line laser instrument, which is XT440, is 10 meters. So with the line, we have a larger area where the energy of the laser is shared on. Therefore, the distance is a little smaller with the dot laser where it's very concentrated. The resolution or the accuracy of the instrument is actually not changing at all. It's about how the dot of the laser that is projected over distance is increasing in its size, and that happened. That's a typical phenomenon of the equipment. Now, easy laser found a way, even over larger distances, where the dot projected on the detector is increasing to calculate the perfect center of that laser dot. Therefore, we are not suffering from any influences in regards of accuracy over distance. That happened with other instruments of a likely lower price in the market. So our accuracy over distance is really, really stable because of various features or inventions that are inbuilt in the instrument. Now I know from some application, especially for the line laser, that they have potentially not achieved the 10 meter. It's potentially a little bit shorter, and that is often because a strong sunlight, so radiated emission, is projected towards the detector at the same time when the laser beam comes in. So that means the detector has a little bit trouble to distinguish between the laser light, which is light, versus strong sunlight. And the simplest way to overcome that is to put a little bit shade around the detector to block the sunlight. That's a physical phenomenon that we cannot stop to be happening, but we simply can overcome that by protecting just with a piece of carton the measurement unit to block off the sun. That is very simple possible.
Okay, Sven. I think due to the limited time we have, maybe this is the last question in the session. Can a laser alignment system can be used to check the centering between the two motor bearing housings, drive-end and non-drive-end?
The centering between two, say that again.
Centering between the two motor bearing housing.
So I believe you're talking about line bore. So if you think about a stern tube, in turbine, in gearbox, or an engine, to verify the position of the borings itself, we need to have access to that with the measurement instrument. And that is typically done by taking out the shaft. So we need basically to find a way to access the inner circle of the bore itself. So we having designed brackets for that, but in the first place, the shaft needs to be taken out. Then we are projecting the laser beam to the center of the bore itself. We can reference the laser with basically a procedure to make sure it represents the real center. And then we are using the detector inside of that bore to measure in different angle positions to figure out how that individual bore, how far it is off my laser beam or my reference. And that is a classic for us called line bore measurement. And that is possible even with a small upgrade for the shaft alignment instrument XT770. So we can use the same measurement detector for the purpose to measure inside of the bore. For the laser emitter, since that is only a one direction measurement, we need to have some adjustment possibilities to bring the laser into the right position because it serves as our reference. And therefore we have a second or different type of emitter that allows this positioning on magnet brackets, in tripod, on any kind of other positioning in front of the machine to be adjusted. So the upgrade path from a shaft alignment system XT770 would be to have additional brackets and a different design of emitter with the purpose of doing this adjustment, and then you are ready to go. So Andy has mentioned that the XT alignment app is completely for free on the App Store, and you can basically download it and play. If you look into the app and you look under straightness, there you find the feature called line bore. And it gives you a little bit of an idea of how the measurement is done. But since this is also the last question that, as you said, Pak Joseph, that we are answering, if you have any further questions that we have not addressed yet, or if you come later to the company PT Tiara, to Pak Joseph or others, or even to me and my colleague Andy, we can look in any kind of question to answer to you.
Okay, Sven, thank you for the response for
Thank
the
you.
last questions. I think that is the end of the Q&A session. Before we wrap this up, I want to say thank you to our speaker today, Sven and Andy. Thank you for your live demonstration of the laser shaft alignment and belt alignment. And we truly appreciate
you
the
so
time
much.
and the effort you
Thank you
have
very
dedicated
much.
to this session and for your sharing valuable insights. We hope that our participants who joined today have gained a clear understanding of laser alignment compared to the conventional alignment methods, as well as the benefits of performing alignment work using laser technology. Mungkin bagi partisipan yang hadir di saat ini boleh kasih reaction untuk speaker kita hari ini. Ya.
Thank you, Joseph.
Thank you, sir.
Thank you very much.
Thank you for having us and thank you for participating. Really appreciate.
So Sven and
Thank you.
Andy,
Thank you. Good
in the
presentation.
next session, we
Appreciate.
will be giving away awards vouchers to some of our lucky participants. If you would like to stay and watch the giveaway, you're pleased to, and you are more than welcome. So if you want to leave, you feel free to leave.
Thank you.
Thank
Thank you
you.
very
I think
much. Good.
I think I will stay to see who is the lucky winner.
Yeah, you can stay. Okay.
Me too, me too.
Oke, baik untuk Sobat Tiara sekalian, seperti yang sudah diumumkan di poster, kita akan membagikan 4 lucky vouchers untuk lucky participant pada hari ini. Nah, yang sekarang kita akan membagikan 2 vouchers untuk penanya yang beruntung. Jadi yang sudah bertanya hari ini, kita sudah kumpulkan namanya dan kita akan spin wheel bagi yang beruntung. Mungkin boleh di spin. Oke, kita sudah menemukan pemenang beruntung pertama, yaitu Pak Aswin Malau. Mungkin nanti akan dihubungi oleh tim kami untuk terkait voucher ya. Selanjutnya untuk pemenang yang kedua. Ya, untuk pemenang kedua ada Pak Hengki Krisbiantoro yang nanti akan kita hubungi terkait voucher tadi. Baik, mungkin itu dia Bapak Ibu, Sobat Tiara. Itulah akhir dari sesi webinar kita pada hari ini, dan mohon untuk semua yang hadir pada hari ini untuk mengisi link feedback yang sudah tertera. Ya, nah nanti bagi yang sudah mengisi link feedback ini akan mendapatkan e-certificate, dan juga dari yang mengisi link feedback ini akan diacap untuk mendapatkan 2 voucher beruntung bagi yang beruntung lah. Mungkin itu dari kami, Bapak dan Ibu Sobat Tiara. Terima kasih telah mengikuti webinar kami pada hari ini. Semoga apa yang kami berikan pada hari ini dapat memberikan insight yang baik terkait komparasi dial gauge alignment dan laser shaft alignment. Mungkin ada mungkin Mbak ya? Yang baik, itulah akhir dari webinar kami pada hari ini. Bila ada salah dan kurang salah dari kami mohon maaf. Setelah itu, bila Bapak dan Ibu Sobat Tiara ingin melanjutkan aktivitas, kami persilakan untuk melakukan aktivitas ya. Terima kasih, sampai berjumpa di webinar kami selanjutnya.
Sampai jumpa Pak Yosef.
Terima kasih semuanya.